Hi, Miss Lisa here with another lesson from Chapter 6. Today we'll be looking at Chapter 6.5. Our essential question is how can you graph and locate points that contain negative numbers in a coordinate plane? Objective is you'll be able to describe the location of points in a coordinate plane. You'll be able to plot points in the coordinate plane given ordered pairs, and you'll be able to find the distance between points in the coordinate plane. So, previously, we have plotted on a coordinate plane, but we've only plotted on this first quadrant, quadrant number 1. You've seen the y and x axis. But now that we've introduced positive and negative numbers, you guys are ready to work with the entire coordinate plane. The coordinate plane is formed by the intersection of a horizontal number line. So as you can see here, we see that 0, positive numbers to the right, negative to the left, and a vertical number line. Our zeros here, positive numbers are up, negative numbers are down. The number lines intersect at the origin, so the point 0, 0, or the ordered pair 0, 0 is called our origin, and separate the coordinate plane into 4 regions. So 1, 2, 3, and 4. Those each are called quadrants, and if you remember with quadrilaterals, the word quad means 4. Down here, you'll see a reminder of an ordered pair is used to locate a point in the coordinate plane. This is something you should be familiar with. The first number listed is always our x coordinate, the second number, the y coordinate. So that's just again, review of our ordered pair. So I always like to say make connections. So if you know your ABCs, you know that X always comes before Y. So if you get a little bit confused about which number is which, you can remember that X is always before Y. To plot an ordered pair, you want to first go across and then up and down. So when you say across means left or right, either way. So again, the connection, if you know your ABCs, A is for across, so we do the across number first, and then you do up and down because A is the first letter in the alphabet. So now, if we look here, we want to find out which ordered pair corresponds to the point T. So we need to first find T on our coordinate plane. And now you see there's numbers kind of blocked out, but we should be able to count to find out that number. So this should be 3. So we want to take a look at this. And if we remember what we had stated, that we have to go across first, we would do that. We would go across 1, 2, 3. This is our 3 point. And then we would go down or up. And since it's down, we just count 1, 2, 3. So that means that this ordered pair is 3, 3. So that makes our answer D. So it's that simple. It's just the same thing we've been doing in the past. Except for now we are doing it with positive and negatives as well. Okay, so this is one that you could do on your own, which we'll take a look at this, but we're going to go into the student activity. In student view. It'll make it a little bit easier for the tools. So again, we have first go across, then go up and down. So we want to use the graph to write an ordered pair corresponding to the point. So now we want to find out what is our point P. So point P we want to find here. If you remember, we got to go across first. So we would go across to -3. So I'm going to actually write that so I can hold that in my head. And then we're going to go up to it, and that is 3. So our ordered pair for that is -3, 3. And if we wanted to do Q, we would say we went across left or right to -2. And then we go up or down 0, a distance of 0. So then we have -2, 0 as our ordered pair for Q. Right? And we want to write that in the form of an ordered pair. And it's that simple. You just follow the same rules you've always followed before, and we just have to be mindful of where the locations of negative and positive are. So now, instead of identifying a location, we're actually going to plot the points. So here we see plot A as -2, 3, and B as 0, -3.5 in a coordinate plane. Describe the location of each point. So for point A, I need to go to -2, 3. So if I remember, I need to go across, which is left or right, to -2, and then up or down to 3. And since 3 is positive, that means I need to go up. Well, here's 2. There's no 3, but the number after this blank line is 4. So my 3 is here. I'm going to plot this and then label it as A. So now, if I were to talk about the location, I would say A, -2, 3, is located in quadrant 2, right? So I'm just going to put Q2 for short because we don't have a lot of space here. That's my Roman numeral 2. Doesn't look that nice. All right, so then if we are to take a look at the next one, B, is telling us to go to 0, -3. That means I'm going to go across 0. So I'm not actually going anywhere. And then I need to go up or down -3.5. Since it's negative, we know that's down. Here's my 3. And 0.5 is a halfway, right? That means halfway between 3 and 4. So then I'm going to plot my B point here. Now, if I'm talking about a location, this actually isn't inside a quadrant. Instead, it is on the y-axis. So I would say that this is located on the y-axis. So when you're being asked a location, you will state either one of the quadrants, and if it happens to fall on one of the lines, you will say it's on the x-axis or on the y-axis. Okay, and this would be an on your own where you would plot the ordered pair in the coordinate plane and then describe the location. So we'll do one more here. So I have a reminder here, right, that 1/2, so we see half here and 0.5 are both a representation of half. So a half is located exactly in the middle of a point. So we saw that on the last example as well. So 3 would be across, left or right, and since it's positive, it's to the right. And then -1, since it's negative, it is going down. So again, this one does not have, so that was 3, -1. It's not plotting. Try this again. So this would be my point A, and of course I want to label it. And so if I need a reminder, I'm going to go up here, if I can. Nope, I'm not going to be able to. So you would be able to see that we would be able to mark this as quadrant 1, quadrant 2, quadrant 3, quadrant 4. So I would say this is in my quadrant 4. And I'm going to write the 4 since I'm having trouble drawing my Roman numerals. Okay, and so that is, oh, here we go. We can do it now. Right, so just to verify, here's our quadrant 4. It's in this bottom one. Okay, so you could try those on your own. And we're going to go and move on to finding the distance on the coordinate plane. So we want to look at this example here. It says an archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. So that's the distance we're counting by. It's going to count for meters. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? The length of the chamber is the distance between -4 and 5 and 2 and 5. The width of the chambers is the distance between 2, 5 and 2, 1. You can use absolute values to find the distance between points. So we actually learned about this and reviewed this on the number line when we introduced negative and positive numbers. So we did learn this before, so we're going to kind of tie it in. To use absolute values to find the distance, we want to subtract absolute values when the line does not cross the x or y axis. So that's when you have something just in one quadrant. But when we have a line, so like a shape with a line, like a length or a width that crosses over the x or y axis, we need to add the absolute values, the two absolute values together, so the two distances away from 0. So let's take a look at that. So one of the first steps we want to do is actually plot the points. So that's done here. We have -4, 5 here, and then 2, 5 here. So what we could do then is draw a line to connect the dots. Then the next one is 2, 5 and 2, 1. So they said that this is our length up top and this is our width. And if we continue to connect our dots, we could see that this makes a rectangle. So what we want to do here is find the distance of the length and the width. So since I have width written here, now recall I said if it does not cross over the x or y axis, we could just use our subtraction method that we've done a couple of chapters ago, which is where we learned we can actually stack our ordered pair here, 2, 5 and 2, 1. And then we just subtract the numbers that are different. So we can say, all right, this is the same. Our distance is going to be 5 minus 1, which is 4. So our width is 4. Since this coordinate plane counts by 1, we can verify that just by using our counting method. From here, this is distance 0 to here is 1, 2, 3, and 4. So our width is 4. And if you recall, each unit is a meter, so this is 4 meters. Now, to find the distance, here it crosses the y-axis. So now what we could do is find the absolute value from 0 to this point. So since this is from 0 to -4, the absolute value of -4 is 4. So this distance is 4 on this side of the y-axis. And from here to here is a distance of 2. So the absolute value of 2 is 2. So then we can add these two values. Since we're calculating distance, we're going to use the absolute value. 4 plus 2 equals 6. So our length is 6, right? So this is a unit of 4. We'll verify that. From here is 1, 2, 3, 4. From here is 1, 2. So then together we should have 6 if we count 1, 2, 3, 4, 5, 6. So we have 6 meters for the length. So now if you recall in previous chapters, the reason why we would use the subtraction method or this absolute value method instead of counting the 6 meters is because we don't always have our units count by 1. They could count by 3, they can count by 5, they can count by 10, any number actually that makes sense for the data that's being given. So when you use these methods, you're likely to get a more accurate answer because you don't have to worry about what the units are counting by. Okay, so then once we have that data, we can take that information and now we can find different information. So I'm just going to go back really quickly. We had a distance of 4 meters and 6 meters. And now we can substitute those in to find area and perimeter. This doesn't actually ask for that. So in the case of this area, we would just then be able to do 6 times 4 and get 24. And if you recall, since it's meters, we would do meter squared. And perimeter would be 2 times the length and 2 times the width. So I'm going to do 2 times 6, which is 12, plus 2 times 4, which is 8. Oops, this is 4. I'm going to write 8 because I'm silly. So then I would have 12 plus 8, and we would have 20 meters for our perimeter. So that's how you would extend this information and apply it in a new way. And you may see that in some of your activities, but it's super simple now. Okay, so next up, we want to think about time series graphs. So these are line graphs that can be used to display data that is collected over time, connect order pairs to show patterns or trends, and we use this information to make important decisions about business, health, and the environment, and so much more. So we can go ahead and take a look here. Here are some time series graphs. So we're currently at home in quarantine as a whole nation, and even collectively as a world, right? So all over the world, people are at home self-quarantining to help spread the coronavirus or the COVID-19. So these are time series graphs that have been displayed by the state of New Jersey governor, and they are used to represent why we're social distancing and what the impact of it is. So they're using it to make decisions based on how long we should be social distancing and things like that. So if we look at these, if we go to any point, so it's saying that this would be our x-axis as the date of April 29th. And if we went to this point, right, we would say that our ordered pair would be 429, and I would say maybe like 1,800 hospitalizations, right? But we're looking at people that would need ventilators. So you can use this as a way to graph the different points on there, right? And then once these are graphed, then people make these fancy lines to connect the trends. And so what you can see here is the people that would need to be hospitalized if we weren't staying home would be much greater than if we do 31% social distancing, right? So on April 27th, it would probably be somewhere right here, which if we look at the blue line over here, it is already, oh, this is April 29th, I'm sorry. April 29th is already at 60,000, right? And at this date, it's just under 10,000. So we're showing a significant decrease, and you can visually see that without comparing the numbers when we can draw these graphs. And so that's why we use time series graphs, and that's the benefit of them, is that we can actually see the data and what it's trying to show us without having to look at the actual numbers. This is another one where you can plot and graph a line, and the line indicates an increase. And we saw this when we were plotting in previous chapters, right? So this is showing the growth of the virus in different countries, right? So each line represents a different country, and it starts at the point where they had 100 cases, and then you can see how quickly the cases increased over time. And when this graph was presented to the world, China actually had the highest growth rate, and we can see that just by looking at the data. Their line has the steepest incline, and they're above all of the other countries. Here's another example, right? So this is comparing over time the usage of social media and the percent of adults who say they use social media. So each line represents a different age group, right? So this age group, 18 to 29, in 2006, right, there were less than 25% of people. Now, if we look in 2018, it rose all the way up to 88% of adults in this age range use social media. So these graphs show us that in every age group, there is an increase in social media use over time. And we can see that just by looking at the graph. So now we're going to use the data to see, right? So this is kind of what happens first. You collect data. And this is kind of the type of math that I think is a little bit important. Why? Is because as a consumer, as a concerned parent, as a citizen of this country, you're going to see these kind of graphs all throughout your life, whether it's when you're learning to invest and you're planning for your future, whether it's understanding what's happening socially around you, or if there's a current medical emergency, kind of like what we're going through now, to understand what's happening. And these kind of data collection and graphs are created in so many fields. So whether you're planning to be an environmentalist or a veterinarian, chances are you are going to have a lot of data that you need to kind of understand, interpret, and sometimes share with other people. And these graphs allow us to do that. So in this real life example, we're talking about a blizzard hits a town at midnight, and the table shows the hourly temperatures from midnight to 8. So they collect this data and say hours after midnight. So this is going to be our x-axis. So 0 would be midnight, right? So that is our starting point. We said midnight is when we're starting. This is 1 hour after midnight, which would be 1 o'clock, 2 a.m., 3 a.m., 4 a.m., 5 a.m. But it's just saying that they're after, and this is 8 a.m. Then it records the temperature. So the temperature looks like it's decreasing until 8 a.m. So if we are to take a look here, the first thing that you would do is you would want to display the data in the line graph. So we don't have a full coordinate plane, but we do have quadrant 4 showing, which typically you haven't used in the past. So what you want to do is you want to take this information in your graph and then you turn it into an ordered pair. So this is 0 as the x-axis and the temperature as the y-axis. And so we did that for each one of them, turning them into an ordered pair. So then once that's completed, you can go ahead and plot it. So we're going to go 0 across, right? So across first, and then up to 7. This is at midnight. This is the temperature, 7 degrees. At 1 a.m. or 1 hour after that, the temperature goes down to 5 degrees. At 2, we're going to go across 2, up 3, and this looks like a decent drop, right? And then now we're going to go across 3, but now it drops to 0 degrees. So now we're exactly on the x-axis. In 4 hours, 1 hour more, it goes down to -1. 5 goes down to -4. At 6 a.m. or 6 hours after, it goes to -5. At 7, it goes down to -2. So it actually goes back up. So it got warmer. And then at 8, it goes to 2 degrees. So that's positive here. So I really wish I could do a smaller one. Let me see if I can use this. So I'm going to use this to draw my line. All right, so this is how we would create a line graph. This is how any line graph's created. You kind of create these plot points. And then you connect the dots. And the dots and the lines can create any pattern with the line. So we see a decline in temperature until 6, and then an incline after that. So we can make a statement such as, so it's asking us make 3 observations. So just by looking at it, we can say the temperature decreases from midnight until 6 a.m., at which point it increases. We can also look for a pattern where we're saying, where does the temperature decrease the most? So if you see this is a big straight line, so this is the distance from -1 to -4. So if we use the absolute value, that would be 4 to 1, that would be 3 degrees. And then this is also a decent one, and this is from 3 to 0, which would also be a distance of 3. So we can say that the temperature decreases the most from the hours of 2 a.m. to 3 a.m. and from 4 a.m. to 5 a.m. Or from 2 a.m. all the way till 5 a.m. We have the most dramatic drop in temperature. And then we could also make a statement saying something like after 3 a.m. until about 7:30 a.m., the temperatures are below 0, right? So that's another observation that we could make about this graph. And that is information that's easier to see when we look at the graph than when we look at the numbers, which is why we use graphs to begin with. Okay. We just did that. So this would be something that you would do on your own. We're not going to do this together because we just kind of went through this. If you were in class with me, you would make your own data chart here, line chart. And then here's an exit ticket. Again, if we were in class, you would do this and you would be ready for the Big Ideas assignment 6.5. So I think you guys will all be successful at this. You all have skills working on the coordinate plane, and now it's just a matter of remembering the order across, then up and down, and you'll be fine. Thank you for watching. Good luck on your assignment, and until next time, see ya.